Okay, we're going to talk about prisms and rainbows, things like that. So the first thing to talk about before we talk about prisms is that light is made up of different colors, and the colors depend upon the wavelength and frequency. So we show the blue is around 400 nanometers, the darkest blue, and then we come over to the red side, which is around, looks like about 750 nanometers. So the shorter wavelength is the ultraviolet, and the longer wavelength is the infrared. So when we see white light, it's really a combination of all these lights put together. So all of the parts of our eye are stimulated, and that creates the impression of white. And if we take a white light, which is a mixture of all colors, then we put it through a prism. A prism is just an object that takes light and refracts it through two surfaces. Coming out of the other surface, we don't see white light anymore. We see the individual colors that make up the white light. So why is that the case? Well, it turns out that the refractive index, which is N, index of refraction, or the refractive index, varies depending upon the wavelength of the light. So let me zoom out just a little bit. So what we have are 5 different kinds of glass and quartz, and here are the wavelengths at the bottom, which span the range of wavelengths that we see in visible light. And we see that at the shorter wavelengths that you have a higher index of refraction than you have at the long wavelengths. So the individual wavelengths that make up white light are separated, because what happens is that the white light comes in, the red light has less refraction than the purple light, and then when you go through it again, you get additional separation. And if you have if you show the light that comes out of the second surface on a sheet wall or whatever it is, so that you can see the lights, you'll see they're spread out. Further this is away, the wider the just from geometry, the wider each color is. And you could also take these, and if you wanted to get them, you could recombine them, so you can take the individual colors, put them back together, and get what we would perceive as white light. So that's the basic idea with why you get a rainbow that goes through a prism. It's because each frequency of light bends a different amount, and therefore they get spread out. They get separated, and that gives you the rainbow-looking thing. So the question is, what happens when you have a rainbow? Why does that do what it does? So you have a droplet of water, and so it's just like a glass prism. It has an index of refraction of 1.33, and the red light and the purple light are going to bend different amounts when they hit the surface. So you're going to bend this white light in the vacuum or in air. It's going to bend towards the line that's perpendicular to the surface. So if I drew a line perpendicular to the surface, it'd be like that. So it's going to be bent towards that line. The purple one, which has the glass has a higher index of refraction for purple, is going to get bent more, and the red one is going to get bent less. And then you have internal reflection inside the droplet of water. So it bounces back through here, and then it gets bent. And again, same like with a prism, it's going to get separated even more. So these higher up raindrops are going to give you the red color. Those are the ones that are going to go to your eye. The violet ones are going to go here, and you're not going to see them, but you have raindrops that are lower, and so the red in that case is going to miss you and go below your eye, whereas the purple one is going to go into your eye. And so you see that rainbow from red to purple, and you can see on the right hand side here that it goes from purple, orange, yellow, green, blue, violet. And it always goes that direction. You always have the red on top and the blue on the bottom.